Okay.
Presentation.
So WebAssembly. So first, where do we go next? Failed already. Okay, yeah, about me. So I'm a little bit of like a flaky millennial, probably Lad Bible's target market, I'd imagine. So I did a chemistry degree, didn't much like that. And then became a banker for a little bit, and I thought I'd be this guy, but I wasn't. And it was really terrible. So now I'm a developer. Not quite as successful as him, but hopefully a little less awkward. So I moved up here like last year, did North Coders, shout out to North Coders. Yeah. And I started at YLD like 2 months ago, which is awesome, and if anyone wants to apply, I would highly recommend them. Okay, so WebAssembly, has anyone used it? Does anyone know what it is? Show of hands. Nerds. Okay, so WebAssembly is a portable compilation target, and that's what I lifted off the internet. Compilation target, it's basically bytecode, and you can compile languages. At the moment, it's only really Rust and C. It's written more for like machines, so it's a lot faster to run. It's got JavaScript web bindings, which is pretty cool. So most web technology is obviously JavaScript, so it's good to be able to like talk to the WebAssembly. Okay, now I said earlier that it only really runs with like C and Rust at the moment anyway. Hopefully there'll be some more languages coming soon. Now I chose Rust mainly because C kind of scared me, and I'm a JavaScript developer, so I went with the safest option. Rust is a statically typed systems level language, and I'm told it's similar syntax to C++, but I've never done C++, so. It allows memory management, but it's also safe. So what that means is you can like tell it when it needs to do its like garbage collecting or not, and it works either way. So for things like graphics and like games, that's pretty useful because you want like high performance. And this is really important. At the moment, it's only really LLVM that works with WebAssembly, and I don't really know what that is, but it's a compiler, and only C and Rust are compatible with it. Okay, so why WebAssembly? And really, like, there isn't really a reason to use it at the moment because it's very much an MVP. But in the future, it's pretty promising. One reason people might want to use it is because it works with different languages, so you can use different languages in the browser if they're C or Rust at the moment. But because we all love JavaScript, I'm not really going to dwell on that, so I'll just move on. The main reason why people use it is because it's super fast. So what we're looking at here is what the just-in-time compiler does, or like a approximation. So a lot more crazy steps going on with different threads and stuff, but this is kind of the vague idea. So we've got the parsing, which is JavaScript needs to go from a language which humans are better at reading to like one that machines can read that. So that's the parse step. And then it goes through these like compile, optimize, re-optimize, execute, and then garbage collection at the end. So it's super efficient, but it can be improved on, I think. By comparison, this is the WebAssembly. So as I said earlier, it's easier to fetch because it's more compact, and as far as like parsing and decoding, WebAssembly doesn't need to be parsed because it's already like readable by machines, so it only really needs to go through some like validation steps. Compile and optimize, again, it's like closer to the underlying machine code, so it's a lot faster to get it running. And execute, it doesn't need any garbage collection because that's all handled by Rust when it's compiled. Okay. So I implemented this Conway's Game of Life. Has anyone heard of it? Has anyone made it? Cool. For those who don't know what it is, it's a zero-player game, and it was made in like the 70s by a mathematician. I think it was made to model population growth or something like that. So what it really is, it's like a grid of cells, and each cell can either be like active or inactive or dead. And there's only 4 rules that like govern the state of that cell on like the next iteration. I'll come to this when I go through the code. But what you get is patterns kind of like this, and it like iterates. So each time it moves, it's like a new iteration, and the pattern that it comes up with is dependent on like the pattern on the last state, if that makes sense. If I butchered that a little bit. So these are the 4 rules that govern it. So any alive cell with fewer than 2 live neighbors dies. Any live cell with 2 or 3 live neighbors lives on to the next generation. Live cell with more than 3 neighbors dies because it's overpopulated, and any dead cell with 3 neighbors becomes active or live. Okay, so how I did it. Now there's Cargo is kind of like NPM for Rust. There's like some really cool modules you can use with it, and they're called like Cargo. It's a package manager. It's not quite as good as NPM, but I think it will be, maybe, at some point. So I use this WASM pack, which is WebAssembly pack, and basically it compiles it all for you into, you Rust into WebAssembly, and it also sets up some bindings for you, so it makes like really cool like JavaScript wrappers around all your functions, so you can call them easily into like a new, to like an existing web app. And it does that via this thing called WASM bindgen. Yeah, so I should mention that WebAssembly has like a completely different memory to like JavaScript. Obviously, JavaScript is all garbage collected, whereas WebAssembly isn't, so it's kind of stored differently. WebAssembly has a linear memory space, which means it's completely distinct to JavaScript. Yeah, as I mentioned, JavaScript can read this, but only as an array buffer, so we need to make use of like pointers. So you can't, if I was to do this Conway's Game of Life in like pure JavaScript, I'd probably do like nested arrays. I'm sure many of you would do that as well, but you can't really do that with Rust like linear memory, so you have to do just like a flat array. And I use this function to get the indexes. I'll go into that when I jump into the code, which is now, if you could like hold this while I, yeah.
Absolutely. I will cherish this crucial role while you mirror the screen.
I need to mirror this.
Are you good?
I'm good, yeah. You'll hear me without the mic.
Yeah.
Yeah.
I think it might be better for the recording though.
Okay.
As nice as it would be to choose.
Okay, so has anyone used Rust before, or written any Rust? Cool. You probably know more about it than me. I've been doing it for like a month, so. It said apparently it's like C++, but I wouldn't know about that either. So this is my Rust file. So here I'm basically just defining the cell, so that's each individual like cell, and it can either be dead or alive, so define that as an enum. Then we're defining the universe here, which is the grid of cells, so that takes width for a height, and obviously the cells that go into that, and that's in a vector of cells, which is basically like an array. This here is an implementation object. So in JavaScript, when you have an array, you can do like .map or like .reduce off it. This is basically defining what methods you can do off the universe. Okay, so here I've got just the get index and this live neighbor count, which is just counting the number of live neighbors. This is quite important. So here I'm defining WASM bindgen, and that's an attribute. So what that's saying is take everything within this like block of code block and make like JavaScript bindings for it. So I can call these methods in like JavaScript. So we've got some like getters and setters, which is just like pulling with height the cells from the memory. And then this tick method is calculating what the state of the universe is going to look like on the next iteration. And then we've got this new, which is basically just like an initialize function. So all these will be available to me in JavaScript. And I'm going to show you, hopefully, how easy it is to compile this Rust into like WebAssembly. But because it's like very new technology and this is actually a beta, it doesn't always work. So we'll see. Okay, cool, so that worked. And what he's using there is the cargo that I was talking about earlier. So it's now made me the WebAssembly file, which looks like this. That's actually just the text representation of it. It's actually binary code, bytecode under the surface, but I think that looks pretty horrific as well. Okay, so it's also made these, which is the wrappers around the bindings that I was talking about. So these are all exported, and now I can call those functions into my JavaScript file, which is down here. Okay, so this is something that we're probably all a little bit more familiar with. So this is just plain old vanilla JavaScript, and I'm just making a canvas and overlaying here where it says draw cells. So I'm making a array from the buffer, which is coming in here by the top, and that is brought in directly from the WebAssembly file. It's also bringing in this universe and cell, which comes from the bindings, which was made earlier. And all it's doing is it's rendering it to a canvas, and then in this recursive function, it's calling the next iteration. So hopefully, I'll show you what it looks like if it works. So yeah, that's the pan. And yeah, that's my talk, so I'll take any questions. Be nice.